So this week, we're going to take a look at solving systems of equations. So it's going to be two sections, 10-1, 10-2. The 2 half days we have, those will be review days. Okay, so remember, when you are solving a system, it means that you're looking for 2 or more answers. Okay? All the systems that we solve this week are either going to have 2 answers or 3 answers. But a system can have, could have dozens of answers. Right? It just depends on how many variables are in the problem. Okay, all of ours will have either 2 or 3 variables. Most of the time, you'll see x and y used for 2 variable problems. And then when we do 3 variable, we'll throw in z. So the first one we're going to look at, we are just going to set it up. We're not going to solve it right away. But it's going to be a problem that you need to know a little bit about rectangles, either the formula for the area, the perimeter, or both. All right, so that's a formula that make sure we know before we start it. What's the formula for area of a rectangle? Length times width. Yep. And what's the formula for the perimeter?
Length squared, or no, length plus width.
Yep, so length plus length, and then width plus width, so 2L plus 2W. Yep. All right, so they're giving us a little bit of information. We're going to fill that into what we just said. We have a rectangle with a perimeter of 100 and an area of 300. Eventually, the goal is going to be to figure out what's the length and the width of the rectangle. All right, so let's start with writing down the formulas. Perimeter. You can write it as length plus length or width plus width, but I'm just going to do 2L plus 2W to shorten that up. And for area, length times width. Okay, so all we can really do is just take the information that they give us, plug it into those 2 formulas. And for now, that's it. They don't actually want us to solve it yet. So what did they give us, Christian, for the perimeter?
It's 100.
Yep, perimeter is 100. So there's our first problem. 100 equals 2L plus 2W. And Maddie, for the area, what did they give us there?
300.
Oh, 300.
You're right, but yes, go ahead. I meant Maddie. So the area is 300. Perfect. All right. Now those don't use x and y. When we go to solve it, if we're more comfortable changing it to x's and y's, we can do that. And maybe for the first one, we will. So the 2 methods that we're going to use to solve problems like that are substitution and elimination. So we'll start by looking at how we do substitution, and then the second method we'll look at is elimination. This problem that we have here is going to be better for substitution. And we'll see why in a few minutes. All right, so when you do substitution, there are 3 steps. Okay, the first step is to pick an equation that you have. You're going to have 2. And then once you pick an equation, pick a letter that you want to solve for in that equation. Okay, so let's get our problem at the same time. Which equation here do you think would be easier to work with? The one on the left or the one on the right?
Right.
Yeah, the one on the right, there's less going on there, right? Less things that we have to deal with, because the goal is going to be to solve it for a particular variable. And we could do that with the one on the right in 1 step. With the one on the left, it would be 2 steps. Okay. So you get to pick an equation and then pick a variable that you want to solve for. Once you do that, you're going to have something like L equals, and you're going to have a formula from step 1. you're going to take that formula and you're going to plug it into the equation that you did not use. That's step 2. If you've done step 2 correctly, then at the end of step 2, you should have an equation with only one letter after you do step 2. You'll be able to solve for that one letter, and then you're halfway done. Okay, you'll have your first answer. Once you get your first answer, like let's say you solve this and L came out to 10. So at the end of step 2, you know L is 10. In step 3, you're going to take that answer you just got, 10, and you're going to plug it back into one of the original equations. That'll give you the other letter. So if L was 10, in this case, W would be 30. That is not what it comes out to, but just as an example. Okay, so those are the 3 steps when you are doing substitution. Substitution works well when you have 2 equations that they're not in the same format. So like if you look at this one on the left, another equation that's in the same format as that one would be something like 30 equals 5W or 5L minus 6W. Those 2 equations have the same setup. They each have just a number on the left without a letter, equal sign, a number with L, and then a number with W. This one doesn't have that same structure. It's got a number on the left, that part's the same, but then it has a product of 2 variables on the right. So because it's not set up in the same format, elimination is not a good method for this problem. So we're going to solve this one, but we're going to do substitution. Okay, and I'm going to change everything to X and Y just because that's what we're going to start seeing more of when we do problems. Okay, so that's exactly the system that we just had. I just changed everything to X and Y. And let's go through the 3 steps and see if we can solve for both variables. All right, so we have, we'll call it equation 1 and 2. Which equation did we decide it would be easier to get a letter by itself in? 2. Yep. So let's take equation 2. And what letter do you want to get by itself? X. Okay. So take this. I'm going to solve it for X. How do you get the X by itself there? Divide by Y. Yep. So there's your formula for X in equation 2. X equals 300 divided by Y. All right, what are we going to do with that 300 divided by Y now?
Plug it into X and Y.
Yeah, you're going to take that, you're going to fill that in for X right there. So we're taking the result we just got from step 1 and we're plugging it into the other equation, and then we're going to simplify. So we've got 2y, that part's not going to change, plus 2 times, and now instead of putting x next to the 2, you're going to fill in 300 over y. All right. So now, if we look at it, we should have only one letter. You might see the letter more than once, but you shouldn't have different letters now. Okay, we have all Y's. Any question on that part of step 2? Now we need to simplify what we have and solve for y. So we've got 2y plus, what's 300 over y times 2?
600 over 2y.
So 600 over 2y, that's exactly the same as just 300 over y. Those are the same thing. So when we multiply it by 2, we don't get back the same thing.
So just 600Y?
So think of it, think of it as like 2 over 1 times 300 over y. What would that come out to?
600 over Y.
600 over y, yeah. So not 2y, just 1y. All right, so we get 600 over y equals 100. Now it's going to be easier to solve that equation if we don't have a fraction in it. So what could we do to get rid of the fraction? Yeah, what would you multiply by? Yeah, so let's multiply everything by y, and y. Okay, what do you get if you multiply the first term by y? 2y squared. And then in the second term, okay, the y's are going to cancel out. So we just have 600. And then on the right side, it's 100 over y, 100 times y. Now we've got an equation where the highest exponent is a 2. What kind of equation has the highest exponent as a 2? Yeah?
Quadratic?
Quadratic, yeah. It's a quadratic equation. And when we solve a quadratic, what do we try to get it equal to?
0.
Yep, we got to get it equal to 0. So let's bring everything over to the left side. So I'm going to subtract the 100y to get that on the left. Okay, so now I've got my quadratic set up the way we want if we're going to either try to factor it or use quadratic formula. I don't think that one's going to be factorable. But there is something we could do first just to make the numbers a little easier to work with. Anybody see what we could do? Yeah, we could divide everything by 2. It's not necessary. It's not going to change the answer. It's just going to make the numbers a little smaller. So let's divide through by 2. And again, we're not going to be able to factor that. So we are going to use quadratic formula. What's, when I fill this into quadratic formula, what's the a going to be?
Y squared.
What is it?
Y squared.
So a, b, and c are all numeric. 1. Yep. And what about b?
Negative 50.
Negative 50. And c? 300. All right. How does the quadratic formula start off? So that's what we need. Yep.
Is it negative b?
Negative b. Okay, good start. So negative b. And then what comes after that?
Plus or minus?
Plus or minus. Yep, square root. And what's the first thing that's under that square root? There is a 4, but that's later on. Something with b.
B squared.
B squared. So b squared is 2,500. 50 times 50. So now we have b squared, a little bit more under that root. Minus 4ac. So minus 4 times 1 times 300. And then we have to divide that all by 2a, which is 1 times 2. Okay, so let's figure out what we get. And remember, we are solving for y. Okay, we still have to find x. But once we get y, we're like 90% of the way done. All right, so we got 50 plus or minus. What's 4 times 300? 1,200. And what's 2,500 minus 1,200? 1,300. our answer for y. So we're going to make a table because we're solving for a system. So we want to make sure everything's organized. So when we solve for the system, we're going to get two values for y. We could just call them y1 and y2. And I'm going to take that in and round it off. Okay, so the first value is 50 plus the square root of 1300 divided by 2. 43.028. And the second answer is 50 minus the square root of 1300. And that gives us 6.972. Okay. So we've got our two answers for y. What's the last thing we need to figure out?
The answers work.
As long as you've done all the math right, they're going to work. You're not going to get anything that's like an straight A's here.
Like plug it back in.
Okay, you got to plug them back in to do what? To find x. Now, this particular problem has two coordinates as an answer because we had an exponent of 2. It was a quadratic. If this hadn't been quadratic, you wouldn't have had two coordinates. You would have only had one coordinate. All right, so now we got to plug those back in to get our two x values. We already have a formula right here that we can use. The x value is 300 divided by the y value. So just do 300 divided by, and fill in each of those numbers. Okay, so let's see what happens. 300 divided by the first y value. That's our first x value, 6.972. And anyone have a guess what's going to happen when I do 300 divided by my second y value? Yeah, it's going to come out to 43 point, just rounding, it came out to 029. 43.029. But they should be the same. The reason we got two different answers is because we're trying to find a rectangle that had a certain perimeter to it and a certain area to it. Well, when you draw your rectangle, you could draw it that way. Or, how else could you think of that rectangle? Yeah, vertical, right? If you do the exact same rectangle, but do it that way. That's why technically there are two different answers. Both of those rectangles have exactly the same perimeter, and they have exactly the same area. Okay. So, any questions on how we use the substitution to come up with the equation and then solve it with the quadratic formula? All right. So that's substitution. Let's try another substitution one. But this time, if you look at all the exponents on your variables, what's the highest exponent on any of the variables here? 1. Okay, we don't have any exponents higher than 1. So when we solve this, we're only going to get a single coordinate as the answer. But remember, a coordinate has an x and a y value. So it has two parts to it, but it's just a single coordinate. All right, so first step, decide on which equation we want to try to work with. The top one or the bottom one? Top. And which letter do we want to get by itself?
Y.
Yeah. If you have an equation that has a positive 1 in front of it, that's the letter to try to get by itself because it'll be the easiest. Okay, so let's take this. Rewrite it. If y was by itself in that top equation, what would it equal?
Negative 2x plus 5.
Yep. So you'd subtract the 2x, which would make it negative, and then you'd have the plus 5. Since we're not worried about y equals mx plus b, if you had said 5 minus 2x, that would have been fine. Okay, but that is y equals mx plus b, if you want to think of it that way. Okay, so we got y by itself. What are we going to do with that negative 2x plus 5? Yep.
Plug it into the other equation.
For what letter?
Y.
Yep. You can take this and plug that in right there. Because you were multiplying y by something, everything that you fill in for y has to get doubled. So make sure you always put whatever you substitute in parentheses. So now instead of y, we're going to put negative 2x plus 5. Okay, and now we check it. The only letter we have there is x. It appears more than once, that's fine, but we don't have two different letters. Okay, so we've got 3x, and what do we get when we distribute the 2? Negative 4x plus 10. Perfect. Okay, what can I do next on the left-hand side?
Combine that term.
Yep, combine like terms. What's 3x minus 4x? Negative x. Right. Jaden, how about my next step?
Put the 10 on the other side, subtracting from both sides.
Yep, subtract the 10, and what's that going to give me?
Negative x equals negative 8.
Negative x equals negative 8. So then what does positive x equal?
8.
8. Perfect. There you go. So there's your first answer for x. That wasn't quadratic. That's why you didn't get 2 answers for x. That's the only answer, 8. Okay, what do we do now with that 8?
Plug it.
Yeah, plug it back in. We'll take that, plug it back in, right there. And when you fill in 8, then you'll get your answer for y. So we're going to have negative 2 times 8 plus 5. And negative 16 plus 5 would give me negative 11. There you go.
If we just plugged into one of the equations, like say I plugged into the top equation, we got the same answer. Is that right, or not?
Like if you put the 8 in
Yeah.
right there, yeah, you get the same thing.
I was making sure it wasn't like
You could plug, or you could plug the 8 in right there too.
that.
The reason I chose that one is because y was already by itself, and when I plug it in, all the work is pretty much done.
Yep.
Yeah.
You don't have to write your answer as a coordinate.
So you could write your answer a couple different ways. You could do x equals and y equals, like 2 separate boxes, or you could write your answer as a coordinate. Yeah. Because if you were to graph this in y1 on the calculator, and then graph this in y2, that is exactly where they would cross, 8, negative 11. Any question on why they would cross at that point? Okay. But yes, you could write your answer either way. All right, so that's substitution. Let's take a look at elimination. Substitution is okay when you have 2 variables, but when you start getting into more than 2, like we're going with 3, elimination, it scales better. Okay? It works better when you start having to do more complicated problems. All right, so elimination works well when you have equations, 2 equations or more, and they all have the same structure to them. They all have the same kind of format. And the goal is to add one equation to another equation to try to get variables to cancel. Right? That's the goal. We're going to add one equation to another equation to try to get variables to cancel. the way we're going to do it is we're going to try to get coefficients to be opposites. Okay, here's two equations that would be perfect the way they are for elimination. 3x plus 2y equals 10. Negative 3x plus 3y, let's do, 3y equals 15. Those are set up perfect for elimination. Because all you'd have to do is add the equations, 3x, negative 3x, those cancel out right away. And then you just have 2y plus 3y, it's 5y, and 10 plus 15 is 25. And now you're left with a very straightforward equation to solve. But sometimes you don't have that right away, where one of them is a number with x and another one is the opposite of the number with x. Sometimes you need to make that happen, okay, first. So that's what we'll look at. So it might be necessary to multiply either one of your equations or both of them by a constant first. So for example, if I had 2y plus 3x equals 10, and let's say 7y minus 6x equals 5. This is good for elimination because they're both set up with the y's in a column, the x's in a column, and the constants in a column. But I don't have any number here that I can just add a column together and they cancel. Does anybody see a column that could cancel if you multiply the top equation by something first? Yep.
3x?
Yeah, what would you have to multiply the top by?
2.
Right. If you multiply that top row by 2, you'd have a 4y, 6x, and a 20. Well, if you had a 6x here and a negative 6x there, then they would cancel. Right? So that's what I mean by saying it might be necessary to multiply by a constant first. In this problem, you'd only have to do it in the top. But sometimes you have to do it in both. Okay, so let's try this one. So we've got 2x plus 3y equals 5, and negative 3x plus 5y equals 21. Now, it's not that you couldn't do substitution in this one, but the goal is to try to solve it in as easy of a way as possible. That's the goal. So this one is going to be set up better for elimination. Which column do we want to try to get to cancel out? We can pick either the x's or the y's.
X.
Yeah, I pick the x's because the numbers are smaller. So if you pick a column with smaller numbers, arithmetic might be a little easier in your head. Now, we're going to have to multiply the top one by something and the bottom one. What could we multiply the top equation by? 3. Okay, so let's multiply the top equation by 3. And we're going to put that next to it. So that's going to give you 6x. It's going to give you 9y equals, and then you're going to have 15. 6x plus 9y equals 15. Yeah?
On the test, are we going to have the choice between substitution and elimination?
I think for most of the problems, you'll be able to pick the method. There might be one or two that specifically say, like, use substitution. Yeah. But on a lot of them, you'll get to pick. All right, so we're trying to get the x's to cancel, which means somehow we've got to get a negative 6x in the bottom. What could we multiply the second equation by? 2. So let's multiply that by 2. And then 2 times negative 3x gives you negative 6x. 2 times 5y gives us 10y. And 2 times 21?
42.
42. Perfect. Have a good day. All right, so now add your equations up. 6x plus negative 6x. That's gone. What's 9y plus 10y? 19y. And 15 and 42. 57. So last step is going to be to divide each side by 19. And that won't always come out nice, but it does in this one. Yep, y comes out to how much? 3. Okay. Now, because we didn't use substitution, we don't have an equation that already says x equals, and then we just have to fill y in. So we have to pick whichever one we think is going to be easier. Top one or bottom one? Top one. So now we're going to take the y, and we're going to fill it in right there. So we've got 2x plus 3 times, and we filled in the y, which was 3, equals 5. Okay, so 2x plus 9 equals 5. Bring the 9 to the other side. And 5 minus 9 gives me negative 4. And divide by 2. So x is negative 2. So that's a problem with elimination, where we had to multiply both equations. Okay. Any questions on that? All right. So when we are solving, this is a linear system. Right? If you were to graph this in y1 and you were to graph this in y2, they would be 2 lines, and they would cross at negative 2, 3. What else could happen when you draw 2 lines besides crossing at a single point? They might not cross at all, so they could be parallel. And what else could happen? They could be the same line. So those are the 3 cases that can happen when you are solving linear systems. Okay, that problem we did with the rectangle right away, that wasn't linear, that was a quadratic. That was different. But when you're solving linear, if you graph them, they could cross in one spot. They could be parallel lines, which means they never cross. Or they could be exactly the same line right on top of each other. So no solution and infinite solutions. Those are 2 special cases, which we'll take a look at right now. All right, so let's look at this one. Again, substitution or elimination. You could choose either method, but which one is this one kind of set up for?
Elimination.
Yeah, it's set up for elimination. Make sure you've got your x's in a column, y's in a column, and then your constants in a column. Which column do we want to try to eliminate? The x column or the y column? Well, let's just pick one, focus on that, and if something magically happens to the other column at the same time, then we'll see what happens. So let's pick a column to focus on. All right, we're going to focus on x, which means we could multiply the top equation by what? 3. Okay, so our goal is to eliminate x. What's the new equation when we distribute 3 to everything?
6x minus y
15. And now your bottom equation, this time, you don't need to multiply that by anything. 6x plus 9y equals 10. What happens when you add your x's up? Cancel. And when you add your y's up? Cancel. So what do we have on this side now? 0. Everything canceled. And on the right side? 25. Okay, when all your letters cancel out like that, you end up with a numerical statement. You're done. We just have to interpret what that means. 0 equals 25.
No solution.
Right, that means there's no solution. That's not, this is a false statement. The answer is not false. The answer is because that's false, we don't have any answers. No solution. So if we were to graph those two lines, what would they look like?
Parallel.
They'd be parallel. Yep. They have the same slope, but they would have different y-intercepts. Okay, so that's a no solution. All right, let's look at this one. Again, is this set up for substitution, elimination, or either one? Yeah, you could do either one because this has a coefficient of 1 in front of it, which would make it easy to solve for x. Since we've already done some substitution, let's do this one with elimination. What column do we want to make cancel out?
X.
All right, so let's focus on just one column. Focus on the x. And what would you have to do to make the x's cancel?
Times by 2.
Yep, and times it by 2. So bottom is going to stay exactly the same. What do you get when you multiply the top by 2?
2x minus 6 minus 30 equals -4.
Equals -4. And when you add up the x's,
Cancels.
they cancel, the y's.
Cancels.
So we're left with 0. And -4 plus 4? 0. So again, same kind of thing happened. All your letters canceled out. But this time we got 0 equals 0. That's a true statement. So what do you think that means here?
All numbers.
Right. Okay. This has an infinite number of solutions. Okay, so if we solve that, it has an infinite number of solutions, so it's all real numbers. Any question on that? All right, so that's substitution and elimination with two variables. When we go to 3, we're not going to do substitution because it works, but it starts to get kind of time consuming. All right, so elimination with 3 variables, it's just like 2, except it's some more steps. All right, so I'm going to show you the, I'll write down the steps and then we'll go ahead and we'll do a problem. So the first thing you're going to do is you're going to have 3 equations, okay, like this. 1, 2, 3. You're going to pick one variable to eliminate in 2 of the equations. So we'll number these. You're going to pick 2 equations, and you're going to try to eliminate a variable. And we have to do that twice. So pick one variable to eliminate in 2 of the equations. Then we have to eliminate the same variable in 2 different equations. So like when we do this problem, maybe we'll choose to eliminate x in equations 1 and 3. And then we'll choose to eliminate x again in equations 2 and 3. But we have to use 2 different equations the second time. Once we've eliminated one variable in 2 different equations, this is now going to be just like the problems we did before. We're going to be left with 2 equations. Each equation will have 2 letters. And then we'll solve that like we've been solving. So we do that first, and then using the 2, bless you, using the 2 new equations from the first step, say eliminate another variable. So after you do that step, now you're going to have one equation with one variable. And now you'll be able to solve for that one variable. So solve for the variable that's remaining. It could be x, y, or z. Depends on how you chose to do it. Once you solve for that variable, then you can use substitution, just like we did with two variable, by plugging it back in to get your other answers. So we'll finish off by substituting in the answer back in to get the other ones. So even though we only have one more variable to solve for, it does end up being quite a few more steps. Okay, we have to do elimination several times. And then if you went to a 4-variable system, it starts to get really pretty bad. So we'll be sticking with 3. All right, so when I give you a system, you want to look at it and see if you can find an equation that has a 1 in front of one of the variables. If you have that, it's going to make things a little bit easier with the arithmetic. Do we have an equation that has a positive 1 in front of any letter?
3.
Yeah, equation 3. So which letter has a 1 in front of it? X. Then that should be the letter that we focus on. So let's try to eliminate the x in. What 2 equations do we want to use first? 1 and 3. Okay, so we're going to try to eliminate the x in equations 1 and 3. So I'm going to copy them down. So 2x plus 3y minus z equals -1. And x plus 4y minus 3z equals -8. Okay. What would we have to multiply by, and to which equation would we do it? -2 on the bottom. Yep. So we're going to multiply everything by -2 on the bottom. What's going to happen to the top equation? Stays the same. 2x plus 3y minus z equals -1. And what's going to be my new equation on the bottom?
-2x minus 8y plus 6z equals
Positive 16. Okay, so let's add those up. X's are gone. What do we get when we add the y's up? -5y. And the z's? And the constant, 15. Now, normally we would stop there. That would be our new equation. But in this equation, what do you notice everything is divisible by? 5. So if you notice that everything's divisible by the same number, you can simplify it and make your numbers easier to work with. What would you get if you divide everything by 5 there?
-y plus z equals 3.
Yep. And I'm going to call that equation number 4. So we just created a new equation from the original 3 that now tells us something about the system, but it gives us information using only 2 variables rather than 3. So think of this as like another piece of the puzzle. It's another fact that's true about the x, the y, and the z. But we want to get facts that have less variables in them, so it makes it easier to figure out what the variables are. All right, so now we got to do the same thing again. Let's eliminate x in, but we have to pick 2 different equations. You can't do 1 and 3 again. which ones do we want to pick? And they got to be from the original. Which ones? 2 and 3? Okay, so let's do 2 and 3. So I'm going to copy those down. So 3x minus 2y plus 2z equals 15. And equation 3, x plus 4y minus 3z equals negative 8. Okay, so my goal here is to create another equation with just y and z by getting rid of x. Okay. What would happen to the top equation? What's that? Nothing. We're going to keep that one the same. That one's not going to change. So 3x minus 2y plus 2z equals 15. And what would happen to the bottom equation?
Multiply by negative 3.
Multiply it by negative 3. And what do we get if we multiply the bottom one by negative 3?
Negative 3x minus 12y plus 9z equals -24.
And what goes on this side?
Positive.
24. Okay, so x's are going to cancel. What about when we add up the y's? Yep, negative 14y. And when we add up the z's? 11z. And when we add up the constants? 39. Okay, so that is another new equation. And we'll call that one equation 5. Any question on that one? All right, so now we're going to take equations 4 and 5. Okay, we're going to just work with these, and it's just like the kind of problems we've been doing before. We're down to 2 equations with 2 variables. So let's eliminate, and we got to pick a letter. But we have to use equations 4 and 5. Okay. Which letter do we want to try to eliminate in those two? Z. All right. So let's copy them down. Negative y plus z equals 3. And negative 14y plus 11z equals 39. What would we have to multiply the top equation by to make the z's cancel out? Yep, negative 11. All right, what's going to happen to the bottom equation? Stays the same. And my top equation. Positive, yep, 11y. So I'm just going to do minus 11z equals negative 33. Okay, let's add those up. What's 11y minus 14y?
Negative 3y.
Good, negative 3y. Negative 11z plus 11z, gone. And negative 33 plus 39,
Positive 6.
positive 6. Now we've created another new equation. That's equation 6. But the nice thing about that equation is it only has one variable in it. So now we can figure out our first variable. Divide each side by negative 3. And what do we get for y? Negative 2. Even though you only have your first variable, you're like 90% of the way done now. So now we're going to finish off by using substitution. Okay, let's plug negative 2 back in you want to plug it into equation 4 or 5? 4. So negative y plus z equals 3. Okay, so let's do it over here. So this is solving for z. So we got negative 2 for y, fill that in. Negative 2 is how much? Positive 2. And 2 plus what gives me 3? 1. Okay, so we solve for z. This was solving for y. And what's the only letter we have left?
X.
X. Let's solve for x. Now, you can't use equations 4 or 5 to solve for x. How come? There's no x. So you got to go back to one of the originals. You can pick any of them, but I would pick the one that already has an x with a 1 in front of it. So let's use equation 3. X plus 4y minus 3z equals negative 8. Okay, so x is what we're solving for. If we fill in negative 2 for y, what's 4 times negative 2? Negative 8. Fill in 1 for z, what's negative 3 times 1? Negative 3. What's negative 8 minus 3?
Negative 12. 11.
So that gives you negative 11. And finish that by, how do we get the negative 11 on the other side? Add. And what do we get for x? 3. So that's generally the steps that are involved when you're solving a 3-variable system. Pretty much can organize it that way every time. Okay? You create your 2 new equations that have each have the same variable eliminated, and then you solve that like a 2-variable problem. And you've solved for the y and the z, and once you have those 2, you finish off by plugging it back into the original and get the letter you don't have. And that's a 3-variable system. Okay. Any questions on that one? All right. So you won't always get nice answers, but most of the problems that I give you, the x, y, and z will come out nice. So if you start noticing you're getting numbers like 79 over 136, you probably made a mistake and the numbers are starting to get kind of messy. All right. So tomorrow we're going to start to talk about a more efficient way to write down all of this stuff. Okay? A lot of what we wrote here was letters. Okay? There are a lot of numbers, but we wrote the x, the y, and the z a lot. I bet we wrote x, y, and z together probably 20, 25 times. If we didn't have to keep writing down the x, the y, and the z, that would save us some writing. The other thing is that we had a lot of choices. Okay? So that's why this method can confuse people, because you have to pick a letter. So you have 3 choices there, x, y, and z. And then you have to pick 2 equations. You want to use 1 and 3, you want to use 1 and 2, you want to use 2 and 3. There's all different combinations you can use. So there's all these choices. Well, when we start doing this method, okay, with what's called a matrix, first of all, it's going to eliminate having to write all the letters. And second, it's going to eliminate all the choices. So with a matrix, every person will pretty much solve the problem the same way. Versus the method I showed you, people might have made some different choices. So when we write something as a matrix, we can take all of that information and on paper represent it like this. What I wrote on the right-hand side, that's called the matrix representation of this system of equations. It just basically looks at the numbers, 1, 2, 4, that's my top row, 3, 1, 10, that's my bottom row. I put a vertical line right here. That vertical line represents the other side of the equation. So that way we always keep the numbers that were to the right of the equal sign separate, and we know that they were on the right side. Okay, so I'm not really going to talk about anything else about a matrix today, but tomorrow, these are the kind of things we're going to be writing down a lot, which will save us some steps. Okay, any questions on that? All right, so we'll look more at matrices tomorrow. Okay, so for tonight, the homework is on page 541, and it's 1 through 19 odd. So remember, that is due tomorrow. We have class right away at 7:35 to 7:45 to 8:30. We'll go over it, and then that's the plan for tomorrow. So we won't be doing a new section.